All right, here are some things to remember. So it says find the solution, so we'd have to solve for x. So on this side, combine like terms, and on this side, we'd first distribute 2. 6 minus 4x minus 7, so combine like terms over here. Combining 6 minus 7 is -1, so then you'll just solve for x. So just being careful with your negatives. Add 4x, add 4x. So then we have, that's gone, oh, that one cancels out as well. So on this side I have -1 is equal to -1. Well, remember, if your x's cancel out, either you're going to have no solution or your answer is going to be all real numbers. So in this one, since it's a true statement, -1 equals -1. True statement, the answer is all real numbers. Any number we plug in will work. So if x doesn't cancel out, you'll have one answer. If x does cancel out, then it's either all real numbers or no solution. So if they would have canceled out and we would have got something like -1 equals 2, that's not true. There would be no solution. Okay, with this one, now we have a greater than sign. So we solve the same way, being careful. So combine like terms on each side. So 4x plus 7 is greater than 2x. Distribute the negative, don't mess up on that. Minus 3x plus 6. So then combine these. 4x plus 7 is greater than -x plus 6, solving for x. So add x, subtract 7. So then on this side we have a 5x is greater than -1, divide by 5. So we would say, okay, x is greater than -1/5. That's how we would write this one. Now remember, when solving, if you multiply or divide both sides by a negative, you got to change the sign of the inequality. So if we were to graph that on a number line, you guys, here would be 0, here is +1, here's -1. So -1/5 is somewhere back, if we were to cut this into 5 sections, right here, roughly -1/5, we draw that in. So it's not equal to that, so we'll put a parenthesis, and then it's pointing this way. So look, it's pointing this way, greater than. So that's how we would draw on a number line. Okay, find the solution. If you get something like this, notice there's an equal sign. We're going to need a common denominator. So I'm going to make all the denominators 12. So multiply by 4 over 4, multiply by 3 over 3, multiply by 2 over 2, times sign, times sign, times sign. Times sign, times sign, times sign. So now look, our denominators are all 12, so I can ignore them. Take the 4 and make sure you distribute it through to both. 4w minus 28, I believe. And then we have minus 3w's equals -14. So now you'll combine your w's. So that would be 1w minus 28 equals -14. So solve for w now. Add 28, add 28. So w is equal to 14, and there's our answer. So you could check it by plugging it back in, and you should get the same solution. You should get the same answer. So if we did 14 minus 7 over 3 minus 14 over 4, it should come out to be, it says -7/6. So you would have to be able to do this one by hand. So that's 7/3 minus 14/4 equals -7/6. So then we need a common denominator right here. So we'd multiply by 4 over 4. We'd multiply by 3 over 3. So that would be 28 over 12 minus 3 times 14 is 42 over 12. That needs to equal -7 over 6. This is just me checking my answer, showing you how you could do it. And then I would need to do 28 minus 42. So now we can write it over one fraction. So -14 over 12 equals -7 over 6. And then you say that fraction can simplify. They both can divide by 2. So if I divide by 2, this becomes a 7. If I divide by 2, this becomes a 6. So -7/6. So it did work. So if you want to check your answers, do that appropriately. If I said to graph this this inequality on a number line, this reads any x value is larger than -2. So here's 0. -2 is here. We're doing any x value larger than -2, not including. So I'm going to do a parenthesis, and pointing it this way. Look, there's a trick. The arrow does point that way, just a reminder. Now it wants us to do any x values less than or equal to 3. So 1, 2, 3. So any value below that or equal to that. So at 3, I'm going to put a bracket, and then it's any value below that. So pointing that way. Pretty easy. Now this one's saying any x values between -5 and 7. So let's see here. We're going to go down to -5. It's not including -5, parenthesis. And the largest value is 7. This is what and looks like, as you know. So it's the intersection. And so all of these would be solutions. All right. Now it says graph the inequality. Notice the word or. So remember that if you have two solutions and or, either or answer gets to come. This is the friendly one. So both answers, all the answers get to come. So let's start with this one. Any x values greater than -5. So let's go to -5. 1, 2, 3, 4, 5. Here's -5. Greater than -5, not including, so we do parentheses that way forever. And then at the same time, any x values less than or equal to -7. So over here, we're going -7, so -5, 6, 7. Here's -7. Any x value less than or equal to -7, so that would be a bracket, and then below that. So this is either or. All of these answers get to come. So that's the answer on a number line. And then in interval notation, all of the answers get to come. So we would say from -infinity up to -7, bracket, parenthesis, union, then parenthesis, because it's not including -5, -5 to infinity. That's how we'd write it in interval notation. This is on a number line. So guys, if this one would have been and, it would have been the intersection. So there, look, notice there's no intersection. So if that was true, we would say no solution if it was and, because they never intersect. Okay, so now we have to be able to do something like this. So writing out our own equations. 6 times a number, we don't know what that number is, so I'm going to call that x, increased by 5, is 10 greater than the number. So we have two x's in this one. So 6 times a number, 6x, increased by 5, so that'd be plus 5, is equals 10 greater than the number x. So we'd have an x plus 10. And now we have set that up, we could solve. However, if you read the instructions, it says write an equation. So we've done that, so we could stop, because it didn't tell us to solve. If it did tell us to solve, we'd now solve for x. So it says the difference of a number, we don't know the number, and 8, the difference of a number and 8 equals the quotient of a number and 2. We don't know the number. So the difference of a number and 8. So x minus 8 equals the quotient of a number and 2. So x over 2, because quotient means division. It did say just write an equation, so we've done that, so we can stop. 3/9 of a number decreased by 7 is less than or equal to a number and 9. So I'm going to go, the number part we don't know, x, number x. Okay, so 3/9 of a number, so 3/9 of a number x, so that would be times x, decreased by 7, so that'd be minus 7, is less than or equal to a number and 9. So x plus 9, because a number and 9, and is plus. So that's how we'd write that one. Okay, so it says solve. So we would need to take 3, distribute it in. So that would be 6r plus 3 minus 5 is equal to, we would take 9, distribute it in. 9r minus 9 minus 3r. Combine like terms on this side very carefully. 6r minus 2 is equal to, combine like terms on this side, 9, 8, 7, 6. So positive 6r is minus 9. Now we'd solve for r. So we're going to combine our r's. Now, something is happening again. -2 equals -9, because those canceled out. So remember, when solving, if your variable cancels out and you have a not true statement, which this is not a true statement, there must be no solution. All right, solve, it says. So you'll have to remember, when solving absolute values, we have to isolate the absolute value and then do the positive and negative. So we have a 3x minus 5 equals positive 4. and we have 3x minus 5 equals positive 4 in the negative direction. So positive 4 distance is what I mean by that. So then solve for x, add 5, 3x equals 9, divide by 3, so x equals 3. Add 5, 3x equals 1, divide by 3, so x equals 1/3. Now remember, there's multiple solutions here, so we write absolute value answers on an interval. So our lowest point was 1/3, and our highest was 3, including those values, because it did land at right on 4. There's a distance of 4 units, so it does include 4. Okay, so first you have to isolate the absolute value, so you would add 1. So then we have x plus 2 is equal to 4. We have a distance of 4, so you'll do x plus 2 equals positive 4, x plus 2 equals negative 4, and then solve in each case. Subtract 2, so x is equal to 2. Subtract 2, x is equal to negative 6. So our solution is from negative 6 up to 2. If you had to draw that on a number line, you guys, you would just draw a number line from between negative 6 and 2 would be our answers. So you would have a 0, 1, 2, negative 1, 2, 3, 4, 5, 6. And then our solution set would be bracket, because it includes those values, and right in there. So we should be good with that stuff. So absolute value here, we have to isolate it. So we add 5. Negative 3 times the absolute value of x plus 2 is equal to, when we add 5 over here, we get negative 3. Now we would divide both sides by negative 3 because we have to isolate the absolute value. So now we have the distance is equal to 1. So we have x plus 2 equals 1, x plus 2 equals negative 1. So x equals, subtract 2, you get negative 1, subtract 2, you get negative 3. So in interval notation, our answer would be from negative 3 up to negative 1. You always list the smallest one first. So graphing that on a number line, 0, negative 1, negative 2, negative 3, it would be like this. All of these solutions in that section right there. All right, doing good. Now remember, if you have two absolute values, you will go x plus 3 equals positive 3x minus 1, and then we could do a positive and a negative, or a negative and a positive. It doesn't matter. I'm just going to go positive is equal to negative 1 times 3x minus 1. You got to use parentheses there, so don't forget that. So solve for x. I should combine my x's first. Let's be smart so we don't start doing weird stuff. Subtract x, add 1. So now we have 4 is equal to 2x, so x equals 2. So we would have x plus 3 is equal to distribute, negative 3x plus 1. So now we'll combine our x's. So I'm going to add 3x minus 3. So I don't suggest doing 2 steps like I'm doing here because a lot of you will make errors. So just do it in sections, like just combine your x's, rewrite it, and then rewrite it again. So we have 4x is equal to negative 2, divide by 4, and x is equal to negative 1/2. So my answers were in interval notation. For absolute values, they'll always be in interval notation from negative 1/2 up to, what was our other solution? Where was it? 2, up to 2. So graphing that on a number line, 0, 1, 2, here's negative 1, so we'd be halfway here. So at negative 1/2, up to 2, and here's our solutions. So remember, with absolute values, you have a positive and a negative, and you will graph it in interval notation and write it in interval notation. Okay, it just is going to say solve. So this is an inequality. So we treat it the same way. We just combine our x's, remembering if we multiply or divide both sides by a negative, we got to change the inequality. So subtract x. 2 is less than or equal to 2x, and then we have a minus 4, so I'm going to add 4. 6 is less than or equal to 2x, divide by 2. So now we have right now 3 is less than or equal to x. But now remember, we wouldn't write it like this. We would put the x first. So we got to put the x first. Now look, it's eating x, munching on x, I said. So it's got to stay the same. You're not changing the sign. This and this are the same thing. Look, it's eating x. So it's got to stay that way. So when the x value is larger than 3, so on a number line, here's 0, 1, 2, 3. Our answer would be or equal to 3, so bracket and that way. All right, right here we have same idea. So we got to distribute negative 3 in, not making an error. So minus 3x plus 6. Put your x's together, combine like terms. So we have 4x plus 7 is greater than, combine these, negative x plus 6. Put your x's together, so I'm going to add x. 5x plus 7 is larger than 6. Subtract 7, subtract 7. 5x is larger than negative 1. Divide by 5. So any x value is greater than negative 1/5. So there's our solution. And we could graph that on a number line. Here's 0, here's negative 1. So any x value is larger than negative 1/5. So right here roughly is negative 1/5, parenthesis, and any x value is larger than that. So that would be pointing that way. Okay, continue. Solve the inequality. Now this one's a compound inequality because we have 2 and the word and. So let's just solve them individually and then put the answers together with an intersection. Subtract 2, subtract 2. X is less than 6. Subtract 5, subtract 5. 2x is greater than or equal to negative 4. Divide by 2. Any x value is greater than or equal to negative 2. So this is the intersection, not either or, it's the intersection. So any x value is below 6. If we were to draw this on a number line, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Any x value is below 6, less than 6, so that would be going this way. And then any x value is greater than or equal to negative 2. So negative 1, 2. That would be any x value is greater than or equal to negative 2. So that'd be going that way. Not including. So it's the intersection. This is the only places they intersect. Right in here. So all of those are solutions. Make sure you use brackets and parentheses accordingly. Now remember, if it's already put together, it's the word and automatically. So we would just solve it the same way, subtract 7 from each side. So then we have negative 7, 8, 9, 10, 11, 12, negative 12. So you're just going to go with it. And equals negative 2. Okay, divide by 2. So now we have negative 6. X is between negative 6 and negative 1. X is between negative 6 and negative 1, which if we were to graph that on a number line, here's 0. Here's negative 1, 2, 3, 4, 5, 6. Any x values between negative 6 and negative 1. Not including negative 6, but yes, including negative 1. So it goes without being said that it's the and because it was already put together. Okay, so compound inequality with or. Solve each. So this one's already solved. Any x value larger than 4. Solve this one, so we would need to distribute 2x minus 2 plus 3 is less than negative 2. Combining like terms, 2x plus 1 is less than negative 2. Subtract 1. 2x is less than negative 3. Divide by 2. So the answer here is any x values below 3/2 or either or answer, any x value is larger than 4. So either or answer gets to come. So look right here. Here's 0, negative 3/2. So here's negative 1. Negative 3/2 is negative 1.5. So negative 2. So negative 1.5. Any x values below this. So right here is negative 1.5. So parenthesis, because it's not including any x values below that, are a solution. And any x value is larger than 4. So 1, 2, 3, 4. And does it include 4? Nope. So parenthesis this way. So this is how you do it on a number line. How we would write it in interval notation is either or answer gets to come. So negative infinity up to negative 3/2. Union or parenthesis. Remember, you got to keep these consistent. Parenthesis or bracket depending. And it was parenthesis, 4 to infinity. All right, another one. So either or answer gets to come. So subtract 3, 4x is greater than. Don't forget if you divide both sides by a negative to change the sign. We haven't had any examples yet. So subtract 3, you get negative 8, divide by 4. So any x values greater than negative 2. Or add 5, 8x is less than 8. So any x value is less than 1. So any x value is below 1 but greater than negative 2. So let's see what that looks like. Either or answer gets to come. 0, 1, negative 1, 2. So if I graph that, any x value is larger than negative 2, so anything that way, or any, and not including, Any values less than 1, not including. But notice, this is taken care of. It's not the intersection, or it would only be from here to here. It's or, either or. So my answer, my final answer is all real numbers. So in interval notation, it goes that way forever, and it goes that way forever. So negative infinity to infinity in this example. It's either or, answer gets to come. From here, it took care of everything that way. From here, everything that way. So all real numbers are included in this solution set because of the word or. Okay, solve the inequalities. You'd say absolute values. We need to isolate the absolute value. It's an inequality, but it works the same way. So just a reminder, we're going to go 4x minus 3 is greater than or equal to 1. Original sign with the positive. Now we got to do negative 1, so we got to change the sign. So we have 4x minus 3. You have to flip the sign, and now just solve them individually. Add 3. 4x is greater than or equal to 4. Divide by 4. So any x value is greater than or equal to 1. Greater, this is an or statement, either or, greater. So add 3. 4x is less than or equal to, when you add 3, you get 2. Divide by 4, divide by 4. So x is less than or equal to 1/2. Either or answer gets to come because it's greater. So on a number line, any x values here, 0, larger than or equal to 1, and less than or equal to 1/2. So I'm going to do it in blue. Larger than or equal to 1, so that would be these solutions get to come, or any x values below 1/2. Well, right here's 1/2, and it's a bracket, and any x values below. Either answer gets to come. So in interval notation, we would say negative infinity up to 1/2, parenthesis, union. Also, then 1 to infinity. Oh, actually, what did I mess up on? We don't want to do this on the test. These were brackets because it was including. So I need to put a bracket here and a bracket here. Okay, so isolate the absolute value. That's the first step. So add 3. So we would have x plus 2 is less than or equal to 3. Now we would have x plus 2 is less than or equal to 3. And then x plus 2 is, you got to switch the sign and do the negative, greater than or equal to negative 3. This is less than. It's not greater, it's less than, so it's and. It has to be the intersection. Subtract 2, subtract 2. Any x value is less than or equal to 1. And at the same time, minus 2, minus 2. Any x value is larger than or equal to negative 5. So if you were to graph that, let's make sure they do intersect. So negative 5 that way, and 1 back that way. So let's see, brackets, because equal to, so we'll do bracket, bracket, and then there's the intersection point. So in this one, in interval notation, we would say from bracket negative 5 to 1. All right, we're doing good. Isolate the absolute value, subtract 6. I meant to have it divide out evenly and nice and pretty, but whatever. Is greater than or equal to, when we subtracted 6, we got negative 5. Divide by 3. So now we have, oh, you know what? We have the distance is a negative. We can't have negative distance. So in this one, people, if you go on and solve it, you're going to get it wrong because you can't solve a negative distance. So this one has no solution. That always is the case. If you have the absolute value equals a negative or absolute value is greater than or less than a negative, it's no solution. So with this one, isolate the absolute value. So you'd add 2. This is all stuck inside the absolute value. When you added 2, we have a 5. Now we can't have a distance of positive 5. So you have 2x minus 3 over 4 is greater than 5. Sign stays the same with the positive. And we also have 2x minus 3 over 4. Switch the sign and do the negative. And this is, look at the original greater. Either or answer gets to come. So I'm going to times by 4 so that it divides out. So we would have 2x minus 3 is greater than 20. So add 3. 2x is greater than, when you add 3, you get 23. Making sure I didn't make any errors, but looking good. Divide by 2. Any x values larger than 23 over 2, and then right here we times by 4. So we have 2x minus 3 is less than negative 20. When you add 3, you have 2x is less than, add 3, we get negative 17 divided by 2 divided by 2. So either or, this is an or statement, so either or answer gets to come. So on a number line, if we were to graph this, we have a negative 17 halves. If you needed to know where that was located, if there was tick marks, you would do 17 divided by 2 in your calculator, like a basic calculator, so you can know exactly where that is. 17 divided by 2 is approximately, it's 8.5. So this is actually negative 8.5. So just so you know, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's negative 9. So 8.5 is halfway right here. Negative 8.5. So it's not including, and then isn't it going that way? Any x values below that. And then 23 divided by 2, if you wanted to know where that was located, that's about 11.5. So on number line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10, 11, 12, 11.5. So graphing that, x value is larger than 11.5, not including, so that would be that way. There it is, graph on a number line. Either or, answer gets to come. So in interval notation, we'd say negative infinity up to negative 17 halves, not including union, then 11.5, or we would call it 23 over 2 to infinity. So hopefully that's not going to throw you off just because you get decimals. Okay. Now if I said to you solve for variable a, that's get a alone, piece by piece in the correct order. So I'd subtract 2y. So we would have negative 3a's is equal to d minus 4c minus 2y. To get a alone, we'll divide both sides by negative 3. And now look, a is alone, so there's our final answer. I'm not too worried if you don't take the negative up. But if you did, if you were like, oh yeah, we don't want a negative on bottom, you would just take and distribute the negative through to each of these. So that'd be negative d plus 4c plus 2y all over 3. And that would be a alone. I'll accept either answer though. I will not accept if you make an error though and distribute it in the negative, so be careful. Okay, solve for a. It's the same instruction, solve for a. Now look, we have an a, we have an a. Remember, if you're solving and you have 2 of that variable, you get everything with that variable on one side of the equation and everything else on the other side. Now look, this one, L2LH, that's an H, does not have an A, so we need to move it. So I'm going to subtract 2LH. Subtract 2LH. So I have S minus 2LH is equal to 2LA, and now we have plus 2AH. Now, everything with an A is on one side of the equation, and everything else is on the other side. So now I can factor out an A. So pull out an A, divide by A, divide by A, so then that divides out, that divides out. So left over is 2L plus 2H. So this is what we're looking at right now. This. Now to get A alone, notice factoring out the A helps because this is a times sign. You'll divide by 2L plus 2H. Divide by 2L plus 2H. And now we have A alone. A is all by itself, so there's our answer. Don't be dividing things across addition signs and subtraction signs because that's a big no-no. So don't start dividing out some weird stuff here, like 2's or the L's. You can't do that because of the subtraction sign right there. Okay, find A united with B. Smiley face means everybody gets to come. So in this we have numbers 1 through 10. 4, 5, 6, 7, 8, 9, 10. And then on this one we have odd numbers, which we have them all listed here. So we have everything in A union B. A intersect B, that's picky. It has to be where they intersect and only where they intersect. 9, 7, 5, 3, 1. 1, 3, 5, 7, 9. Okay, so now we're going to have the story problems. Guys, I can't give you enough examples exactly how you're going to see the story problems. Just understand that when you see a story problem, try to think about how it would work in like the real world. Like just don't overthink it or underthink it. But guys, I know you can do the story problems. Just think about how it would be in the real world, like how you would set this up. So think, if you can't do the story problems, you're going to miss a huge portion of the test. So you have to just be able to think. So it says Glenn works as a computer salesman and earns $400 weekly plus 8% commission on his weekly sales. If he wants to make at least $750 in 1 week, how much must his sales be? So let's set this up. So originally he gets $400 every week. Plus he gets some amount more of money based on how well he sells. So he's going to get some more amount. We don't know that amount. And he doesn't get that full amount though. He only gets 8% commission. So you're going to times that by, so it's a times 0.08. That's 8%. That's a time sign. But I'm going to erase it because we're just going to remember it's time it says. So it wants to know that's how much he can make in a week. So think about how that would work in real life. If he sold $20 worth of that, he would get 400 plus 8% of $20 and so on. It says how much will he have to sell to make at least, so we want it to be greater than or equal to, because we want to make at least $750. So we want this amount to be greater than or equal to $750. So it says if he wants to make the $750, how much must he sell at least? So solve for x now. Subtract 400, subtract 400. So now we have 0.08x, because multiplication can be reordered, is greater than or equal to 7,654,350. And then you'll divide by 0.08, divide by 0.08. So you'll take your calculator, you'll have a little 1, 350 divided by 0.08. That is an x value larger than or equal to $4,375. So he has to sell $4,375 worth of stuff he's only going to get 8% commission of that, and then plus 400 would finally make it larger than $750 that week. So the least amount he would have to make is $4,375. Okay, a recreational center offers children's birthday party for $75 plus $5 for each child. How many children were at a party if it cost $145? So guys, think about it. In the end, a party costs someone $145. We know that this company charges $75 just to have the party. But then they charge an additional $5 depending on how many kids. We don't know how many kids. So $5 times the number of kids. If there's 10 kids, it's going to be 5 times 10, which is 50. So that makes sense. So now it says, how many children were at the party if in the end it cost us this? So now solve for x. Subtract 75. So now we have 5x is equal to 145 minus 75, which is 70. Divide by 5. So x is equal to 70 divided by 5 is 14. There must have been 14 little children there. Okay, let's read this one. Rick is building a rectangular sandbox for his daughter. So kind of draw yourself a picture. Here's a rectangle sandbox. He wants the length, here's width of the sandbox to be 2 feet more than the width. Now understand, we have no idea what the width is. We call that x. It wants the length, though, to be 2 feet more than that. So we would take that and add 2. It says, you have 20 feet of lumber to build the frame. Find the dimensions of the sandbox. So guys, that's perimeter, right? If I want to know that he has a total of 20 feet worth of product, how can we set up a true statement? Isn't it true that this plus this plus this plus this needs to equal 20? Well, this is also x plus 2. This is x. So my true statement would be this side plus this side plus this side plus this side needs to equal 20. And then we can solve for x. So 1, 2, 3, 4 x's plus 4 equals 20. Subtract 4. 4x is equal to 16. Divide by 4. So x is equal to 4. That means our, go back up. The length is, or the width is 4. So then 4 plus 2 is 6. So you would say the dimensions are the width is 4. The length must be 6. And that will give us a perimeter with a rectangular box of 20. Okay, it says the sum of 4 consecutive numbers is 46. What is the number? So let's see here. Remember, consecutive means one right after another, like 1, 2, 3, 4, 5, for example. Those are consecutive numbers. We don't know the first number, x. This would be x plus 1, x plus 2, x plus 3, and so on. It says the sum of 4 consecutive numbers. We don't know the first one. We don't know the second number, but we do know it's x plus 1 because it's consecutive. We have an x plus 2 and an x plus 3. So that's 1, 2, 3, 4 consecutive numbers. The sum is equal to 46. Then solve for x. 1, 2, 3, 4 x's. 1, 2, 3, 4, 5, 6. So plus 6 equals 46. So subtract 6. So 4x equals, subtract 6, you get 40. So x equals 10. So the first number, x, is 10. So the next consecutive number was 11, then 12, then 13. There's 4 consecutive numbers. Add them up. 10 plus 11 plus 12 plus 13. Is it 46? Yes, so we got it right. Okay, that's the end of what I want to tell you to go over. However, there could be other types of story problems. Practice, guys, all types of problems. You should be set.